How exactly did a backup chipmaker turn into an absolute computing titan? Let's dive right into this explainer. Today, Advanced Micro Devices, better known as AMD, commands a mind-blowing market capitalization of nearly $790 billion. But, their journey to this peak, it was anything but guaranteed. It's this wild story of sheer survival, some incredibly bold strategic pivots, and just relentless engineering against the biggest players on the planet.
Section 1. From Clone to Competitor, the early days of AMD.
So, back in 1969, Jerry Sanders and some former Fairchild Semiconductor colleagues started AMD. But they didn't start as innovators, they actually began as a second-source manufacturer. They were cranking out military-grade logic chips, adhering strictly to U.S. military standards. That immediately built the reputation for absolute, rock-solid reliability. Then a massive turning point hit in 1982. IBM wanted Intel's x86 processors for their new personal computers, but they demanded a second supplier. They just couldn't risk facing component shortages. This led to a 10-year technology exchange where AMD actually produced Intel x86 chips. But as the PC market totally exploded, Intel tried to squeeze AMD out. After some brutal legal battles, AMD realized they had to forge their own path. And that culminated in 1991 with the breakthrough AM386 processor. It was a reverse-engineered chip, sure, but it proved AMD could innovate on its own, giving users a high-performance, cost-effective alternative.
Moving on to Section 2, winning the gigahertz race, redefining speed.
Fast forward to the year 2000, and AMD literally shocked the industry. They beat Intel to the historic 1 GHz milestone with the Athlon processor. The secret sauce? It featured a fully independent floating point unit, which is basically a dedicated engine for crunching complex math, giving it superior performance in intense computational tasks. Intel was suddenly lagging behind in the early 2000s speed race, and AMD was out there redefining what high-performance computing actually meant for enthusiasts and pros.
And they just kept the pressure on with a massive wave of industry firsts, completely changing how systems handle memory and multitasking. In 2003, their Opteron and Athlon 64 processors brought 64-bit computing to the x86 architecture. Now, this was a total game changer because they made sure it was fully backward compatible with older 32-bit software. You literally didn't have to trash your old programs just to get next-gen speed. They followed that up in 2005 with the Athlon 64X2 dual-core for consumers. And by 2006, they launched the Opteron Barcelona, the world's very first native quad-core processor, putting all 4 cores onto a single piece of silicon for vastly superior power efficiency.
Which brings us to Section 3, struggles and strategic gambles, the ATI acquisition. Now, maintaining that kind of lead isn't cheap. In 2006, AMD made a massive $5.4 billion acquisition of the Canadian graphics company ATI Technologies. It was a huge signal that they wanted to dominate the graphics market too, not just CPUs. But honestly, it was an enormously expensive gamble that put a severe, long-lasting financial strain on the whole company.
But here's the crazy part. That bold gamble birthed the APU, or Accelerated Processing Unit. This is an incredibly innovative chip that squashes traditional CPU and advanced GPU functions onto one single piece of silicon. It gives you enhanced multimedia performance and just incredible energy efficiency, which is absolutely vital for things like laptops. This specific innovation was a total masterstroke. It eventually won AMD those highly lucrative custom silicon deals for both the Sony PlayStation 4 and the Microsoft Xbox One consoles. And let's be real, those console deals effectively kept the lights on at AMD. Because outside of those console wins, times were incredibly tough. The financial hangover from the ATI buyout, combined with brutal competition from Intel's highly efficient core processors, pushed AMD into massive losses. Their market share was rapidly tanking. So to survive, they made a drastic call in 2009. They spun off their entire multi-billion-dollar manufacturing arm into a new independent company called Global Foundries. AMD became what's called a fabless chipmaker, meaning they totally outsourced the physical production of their chips to reduce their massive capital burden. It was definitely a dark time, but it actually set the stage for a much leaner, highly focused design company.
And that perfectly sets up Section 4, the Zen Architecture Revolution, the comeback.
Enter CEO Dr. Lisa Su in 2014. Operating out of their modern Santa Clara headquarters, she engineered what is arguably one of the most stunning comebacks in tech history. She essentially stripped away all the noise and brought a laser-like focus back to pure engineering excellence. Her singular goal? Build a highly scalable, hyper-competitive core architecture from the absolute ground up.
The result of that relentless focus was the Zen architecture. When it launched in 2017 with the Ryzen lineup, it started a total revolution. Zen finally brought scalable, high-core performance back to mainstream users at prices people could actually afford. They introduced simultaneous multi-threading, so each processor core could handle 2 threads concurrently. They rolled out Infinity Fabric, this super advanced interconnect tech for communication between the cores, and they absolutely nailed power efficiency. By evolving this advanced chiplet-based design from the original Zen back in 2017 all the way to today's Zen 5, this architecture literally turned the company's fortunes around across desktops, laptops, and massive servers.
So let's look at where they are now in Section 5, dominating data and AI, the modern titan.
In early 2022, AMD pulled off its largest deal ever, acquiring Xilinx for roughly $49 billion in an all-stock transaction. This gave them crucial field-programmable gate array technology, or FPGAs. These are chips that can actually be reconfigured after they're manufactured, allowing AMD to push deep into automotive electronics, telecom infrastructure, and complex industrial systems. And if we look at the highly profitable data center space, fueled by their Zen-based EPYC processors, AMD has rapidly closed the gap on Intel. By July 2025, they had captured an incredible 36.5% of the server CPU market. Now, Intel still holds the lead at 63.3%, but this upward trend for AMD is just monumental. It really proves their architecture has become a massive favorite among huge cloud computing providers.
Now they're stepping on to the ultimate battleground, the AI frontier. AMD is taking the fight directly to NVIDIA with their Instinct AI accelerators, which are specialized chips custom-built for the insane calculations required to train large AI models. And the momentum here is undeniable. In October 2025, AMD signed a massive landmark deal to supply OpenAI with 6 gigawatts of AI processors over the next 5 years. As part of this incredible agreement, OpenAI even gets the option to acquire a 10% stake in AMD as long as specific performance targets are met.
So as you wrap your head around this explainer, think about this. With their unmatched momentum in custom silicon, their total resurgence in servers, and now their massive footprint in AI infrastructure, is it only a matter of time before AMD's relentless underdog strategy takes them to the absolute top spot in global computing? What started out as a reliable backup manufacturer has fundamentally rewritten the rules of the tech industry. Thanks for joining me, and keep seeking out the brilliant structures behind the technologies we use every single day.